and various like messaging types and serialization and deserialization, which is used while various approaches. So we are already into that unit, and we already have to discuss about the synchronous communication as well. So message queuing related systems. So whether we have like RabbitMQ or ActiveMQ or the JMS framework or the Kafka, whatever provisions are there. And on the same line, we also have some other cloud-based services for this asynchronous communication. So we'll be taking up that concepts also, and we'll also have some applications based on that, how we can utilize that asynchronous communication, and various tools, open source tools, which are very popular, and many applications you'll find which are already using that, and many cloud service providers are also having integrated support to use those systems. So we'll discuss about that as well, because we are already in that unit, but we are just taking a detour in between. So I'm just going to discuss about Docker related stuff. So that will help you in shaping your applications or innovative assignment and other stuff if you want to apply it somewhere else. So that will be like a production grade deployment if you want to try with any kind of business logic or any domain related application if you are trying to develop. So we already had one practical session on the basics of this. So there you have already tried like creating some Docker container, and there you may have tried very basic commands, so how to move into that, and creating some file inside that container, and checking again that file is there or not. So those were all the like preliminaries of the Docker environment, and we are going to discuss more about exactly what you can do with this and what are the other provisions, and exactly how we can explore that for like a full-fledged application deployment if you want to utilize that. So later on you can also carry forward this in whatever application you are going to develop. So we are just having a detour in between. So this is somewhat on the deployment line. So once you already have your services ready, and then you want to deploy them somewhere. So exactly how you can resolve all those requirements, any dependencies, libraries, and all that. So how you can solve that problem and have your own Dockerized environment to host one or like many services, and establishing network in between, or like creating some storage attachments to that for persistent storage, and other like DNS stuff inside for making the accessibility of the services easy. So not on the IP or port combination, but name-based access to your services. So gradually we'll explore that details of that, and we'll also have more examples on the YAML line, right? So that is YML. And so you'll find many such example files for mainly the application deployment straightforward. So just by following that YAML file, you can straight away deploy your application anywhere on to like local premises or maybe on cloud also if you want to do that. So that we'll just explore that step by step. So we are just writing with some basic stuff about this, and gradually we'll have more detailed stuff. And we'll be taking maybe 2 or maybe 3 sessions as well on this. So when we talk about the virtualization methods, so we have straightforward comparison of virtual machines as well as containers. So when we talk about virtual machines, so it simply gives us a kind of sandbox environment where you can have everything which may be a need of an operating system right from virtualized hardware, and then after the like operating system, whatever you need there, and on top of that, whatever is a requirement as per your application. So you can get all that stuff installed on that machine once it is up, and then it is up to you how you want to utilize that. And the other one, we have the containers. So that is also doing the similar job for us. But there you can have like a very small uh, package containers, which will be hosting part of your application, not fully, right? And we can easily create those containers and can deploy them anywhere in any count. And as per your requirement, you can run them or you can bring them down as per the load, whatever you have during that point of time. And easily you can ship your requirements with whatever dependencies or libraries you have, which are the like need of your service environment. Then only it can be executed in that actual environment. So you can provide that live environment for your service so that it can do its exact task for whatever functional it is designed. So it is having obviously more advantages over the conventional virtualization, and the most important part is like it is very lightweight, and you can easily turn it up. So it's fast enough compared to the virtual machine approach. And there we have the isolation straightforward at the kernel level only. So we have a easy approach to manage these containers on top of the native OS only. So this virtual machine can be taking up a few of your minutes if you are just trying to boot that with your part of the application. It may have its own requirement, OS and kernel and other stuff, your applications, frameworks and other dependencies you have stored into that. So maybe it will be taking some time till it is up. By that time, if you have your containers doing the similar job, then in a fraction of maybe some time, within few seconds, it can be up and running for you. And the last point on this slide is the containers are more efficient when it comes to like portability, or if you want to have like change management, and mostly this continuous integration as well as continuous delivery. So if you want to apply this in your application development, then the containers will be the obvious choice to have better control over this complete process. So there you don't need any kind of guest OS. Straightforwardly, it can run on top of your host OS, and you can straight away take the advantage of whatever like a bin or the dependencies or any other requirements are there. So it can utilize that of the operating system only, and there can be some secondary requirements maybe part of the like containers. Inside that container also you can have several dependencies, and otherwise they can be sharing the whatever libraries or resources if it can be used of the your host OS. So again, the back-to-back advantage what we have compared to VM is only few seconds you can easily get it up for your application or maybe the service. So we have some key benefits here, one by one listed. So we have speed or portability, agility, and we also have a security when it is in the deployment pipeline. And obviously it is providing some cost savings over the conventional way of utilizing your infrastructure. So we have like a fine-grained utilization of all your resources compared to the virtual machine approach. It can be taking up more of your resources when we talk about VM, but in containers we have fine-grained utilization of your all your resources. So it can provide a completely like isolated environment for every container, but on the same point, it can be also sharing whenever it is required, like any binaries or any libraries need to be utilized. So that is also a possibility we have. And easily you can also migrate as and when required with minimum overhead compared to the VM approach we have. So that's the key points we have, like the size of this both either container or virtual machine we have, or the startup time it needs, and when it comes to integration, so just like the continuous integration or continuous deployment when we talk about, or just integrating with your application easily with the other services. So we have more advantages with this when we have the container-based approach. And you can utilize your resources more efficiently. Like if you have virtual machine based approach, then maybe can be killing your resources which are not in use, but maybe in containers we may not have this kind of picture. So you can better utilize your resources with the container based approach. And one line comparison we have between both is virtual machine is based on the hardware level virtualization, whereas when it is containers, so we have on the OS level the kind of virtualization we have, and that is straight away using the kernel of operating system. So we have limited latency involvement there. So now why these containers have evolved? So we have some analogy here. So just like a cargo transport, if you want to have for a variety of objects which are present on the upper half of the slide, and on the bottom half we have some transportation modes which can be used for carrying these various objects from one place to the other place. So there we have like multiplicity of goods, and on the other line we have like how do we ensure that these objects will not like interact with each other. So how do you make that safe from each other, right? And you have multiple possibilities of the transportation modes. So that is your final aim, like whether you can efficiently, quickly, and smoothly transport these objects from one place to other place, and on the way if you have variety of modes of transportation. So that's just a cargo transport analogy. And we have also the application related analogy on the same line. So here we have the term that is metrics from hell. So how do you carry various objects when it comes to like n types of transportation modes? So that is the question to answer. And similarly, we have the same kind of challenge when it comes to application. So we have either a static website, or we have like a database, or you have like a queuing service, or you have some arrangement for analytics related task, right? So how do you want to serve all these API and other stuff? You have some other background process also doing some secondary job for your application. So that is your overall requirement for various tasks of your application. So we have like multiple stack availability here. So how do we again deploy this onto like variety of platforms where we have like developer having his own virtual machine, or we have standalone QS server, or on-premise we have some single server, or can be multiple machines-based clusters arrangement also can be there on the customer side as well. So how do you ensure that everything on the top of this presentation slide you can deploy onto like any platform we have on the bottom side of this slide? So that is a simple question and challenge. How do we solve this? So that's again on the similar line. We have the same term. How do you ensure that deployment of various possibilities of your application onto a variety of this the platforms where it can be deployed at various stages of the application development, right from the inception till it is finally deployed, and there it is like continuously monitored, and then again it can go through certain revisions and changes and all that. So here, excuse me. So here we have some comparison between the various teams here. So like developer team and the production team. So there can be certain conflicts between both the sides of your overall application development, whoever is involved into that. So there can be certain software or some version if it goes through some changes, updates are happening. So maybe developer will be able to do that, but in production it may not be working. So there can be simply conflicts in between the teams, right? So that is again this is because of this variety of challenges only we have for various stacks and various platforms where you need to deploy. So because of this only, we have this kind of conflicts arising between the teams. So straightforward answer to that is we can deploy this in form of the container, and then it can be very easily transported from one place to other place, and without worrying about how it can be carried in a truck or maybe on train or it is a ship or something else. And on the same line, we can also apply the same concept to this application, various possibilities we have. So we can simply host them in the container, and then it can be deployed onto any of this, irrespective of whatever is the capability of that device and whereabouts and all that. We can easily move this also. So many advantages we have this approach. So here we have the separation of concern from both the sides. So we have a DevOps guy, for example, on left, and on right hand side we have a developer. So when it comes to developer, so whenever that person is working as per the role, so that person will be putting all the like code and libraries and whatever packaging related stuff. So applications or data will be embedded inside the container. So that is just packed inside the container. And then after, when it comes to the operations guy, so that person only will be dealing about how do you provide the access to these containers and how do you monitor them, how you play with the networking and orchestration stuff, all that. So that will be the like duty of the DevOps person or the people who are involved in that particular role. So we have a complete separation of concern. So developer will never worry about this stuff, and the DevOps person will never worry about this. But ultimately, we have to expose the endpoints, right? That we already discussed earlier. So your services will have specified endpoints. So how do you expose the functionalities? So from like IP and port combination, or maybe some other named combinations, you are trying to expose the functionality of the service. So that will be anyhow, like it is already taken care over here. And then after, it is up to this side, how that side is managing. So number of containers, how many should be there, and other logging or remote access and all that. So that stuff will be managed by the operations team. So both of them are completely separate, but still they are like working as a single large team. So when it comes to DevOps, so everything is completely working very smoothly, and we have a concept called a single click deployment. So if you just make a change somewhere, then it can be easily pushed throughout the this pipeline, DevOps pipeline, right from the development stage till the production environment. So otherwise they are like working as a single large team, but we have clear cut separation of concerns that who will do what. But otherwise the automation is of that sophisticated level. So we can, with a single click, we can just push all those changes into the production environment. So Docker is just removing that problem, and we can easily deploy this container-based services or whatever technology stack we have on any kind of platform. The only thing is we need some environment to host this particular containers, whether it is one in count or it is many. So that is obvious requirement. We must have that kind of container hosting environment. So this Docker is already there since last maybe 8 to 9 years, and that has already changed the software engineering industry landscape forever since it was introduced. So you can very easily design your code and then deploy that using the containers. So this is simply like a platform as a service. So you can run your container on any kind of hardware combination. Even you are having a virtual machine. So there also you can have like containers running on top of that. So if you have that provision, so inside that also you can have like containers running for you. So with this approach, we can have the ultimate advantage of how you can do fast shipping of your changes or whatever application parts you are developing or services you are developing. So shipping, then testing, then deploying that quickly, and you can significantly reduce that latency, which is otherwise inherently there when you are introducing the changes and when it is becoming available in the production environment. So that is the advantage we have. And whatever is the environment, you can have this sustained everywhere. So what you can use this Docker for? So first point is, and most important, and mostly every industry is just trying to exploit this. So continuous integration and continuous delivery. So there we can easily apply this, and we'll also have later on some examples based on this, either on IBM Cloud or maybe on GCP. So we'll have also the application being created on GitHub, and there will have trigger some changes, and then after it gets deployed onto your cloud environment. So we'll have that kind of demonstration also with the use of the containers later on. So you can easily manage your application as and when required with the deployment, and whenever you need any kind of scaling, either you want to scale up or you want to just take out certain containers. So all those advantages you can simply exploit. So that's what I was just talking about. So you can have your application which we are developing somewhere in whatever SDK or framework you are just developing that, and then after you are just trying to create the image out of that, and then you are trying to like post it somewhere in a public hub, or maybe you have like a private registry. So you can manage it the way you want, and then after the production or like the DevOps so on the operations side, the persons simply can be pulling this, and then they are trying to run the show by applying whatever deployment and scaling and all that managing stuff. So that is like building your application, a part of that, and then shipping via some intermediate arrangement, which is for like a store and forward kind of stuff, and then people can pull as and when required, and your application is right into the production environment, whether it is like a cloud environment or it is like this on-premise if you have some clusters arranged. So that is also possible. So I'm skipping certain slides. I have kept some lines, but I'm not going through all of this. You can read this later on. once I share the presentation. So I'm not going through all of this. So we have more details about the Docker, exactly how many components or objects we have, and what is the brains behind we have. So here we have the Docker daemon, which is running always. So that is, you can call like a main process. And then after we have the uh, complexities being hidden with the REST API approach in between. And then after we have the CLI layer. So whenever we interact with the Docker desktop, for example, I believe everyone must have tried this by now. So the CLI interface with Docker desktop. So mainly you are talking with a Docker daemon by issuing some commands, right? So either like run or stop some container or remove some images and all that, or push or pull all those images. So you are ultimately talking to this daemon through the CLI, but that is happening via the REST API calls. So internally, it is taking up the calls on that line. So it is like a client server approach. So though it is on the single machine, but still it is like a client server approach. So there we have like containers, then we have images, then we have network, then also we have the data volumes. So mainly these are the like four basic objects which are there in the Docker environment. And we'll have access to all this, and we can create this as and when required, and also remove them when it is of no use. So we'll be having more details of this one by one. We'll explore this. So this I've already mentioned. I'm just skipping this. So how this architecture of Docker is, so we have our host. So Docker daemon is there, and we have some containers on our host machine. And then we have some images also are there. So images are just like dead files. And it is not only a single file, but there we have some more complex arrangement of various layers, as in when you have some dependencies getting added into that image. So that also will check like how do you add the requirements for a particular application. If you just recall, while discussing about the API, I had demonstrated that Python like Flask deployment we have seen for resource manipulation, right? So there I have shown how you can Dockerize your application. So there, what I had done, I added this Flask and other requirements into some text file, and then after an image was built, and then after I executed that. So that is the container, and it provides me the complete environment. Otherwise, you have your native installation of all those dependencies, and then again your machine can be serving the purpose. But in that case, the container was serving the purpose with some endpoint specification. So either IP and port combination we have to utilize that exposed functionalities which we are trying to implement. So that is like you can have images in your machine. How many you have so far referred? So it can be in your machine list of images. You can also have several containers on your machine. Some of them may be running, some of them are like down. And we have public registry also. And otherwise, you can also have like a private registry. And the client will be interacting with this system via the CLI. But from client side, we call it like commands. So either build or pull, push or run the container and all that. So all those commands we are issuing from the client side and trying to interact with the Docker daemon, and Docker daemon will ultimately take a call on behalf of the client that what is to be done. So whenever you say pull, so this will just try to get that particular image from the private or public registry, whatever you have configured. So that also you can configure that whatever kind of registry you want to utilize, whether you want to have a private registry or like a public registry, Docker Hub, or maybe you have a cloud-based registry. So it is there on GCP or on IBM you have, or AWS related registries you have for the containers. So that is all you can set as per your requirements. So here we also have a possibility like a Docker client can be talking to a local daemon as well. And you can also talk to another Docker daemon, which may be there on some another system. So remote Docker daemon also may be accessed by a client. Obviously, for that, we need endpoints to contact that. So you can be having like a Linux-based Docker environment, or you can also have like a Windows-based Docker environment. So there we have Docker Toolbox, or straightforward we have the Docker engine we can be also having under this. So generally the preference for the Docker images and the containers what we have, so they are generally on the basis of the Linux platform. So whatever literature or some tutorials you will find, so commands inside the containers, whenever you are trying them, or if you have seen, then they will be on the line of the Linux commands. So that is the most preferred way of having the containers under that environment. Otherwise, you can also have alternately the Docker toolbox. So that will just try to provide whatever kind of like binaries or dependencies which are otherwise not part of your Windows environment. So it will be just trying to provide that extra support for you. So this I already discussed about the registries. So if I just show that, then we have most popular softwares already available on Docker Hub. So if you just check the downloads, right? So it's almost 10 million plus for all the popular applications. Or this we have Alpine or some other stuff also. Otherwise, this is like a generic OS or some language-based requirements and database MariaDB and MySQL and all that. So you can find whatever application is your need on this environment, right? So you can just pull and utilize that without worrying about how to actually install this and how to resolve those dependencies. So just to get rid of that, you can straight away pull this and utilize. Okay, so here we have some demonstration. First of all, like we have our application. It is not exactly a demonstration, just a conceptual diagram we have. So we are trying to build our application, and then we are trying to push this into the container into the registry. So once it is created out of your application, whichever is there, you're trying to create the image, and then we are trying to push that onto the registry. And the other side, wherever it is actually being used in the production environment, so there you can pull it. And if we have some, I think, changes, then this is your base image for your part of the application, right? So if it goes through some changes, like a dash is one change, and then we have some dependencies also added accordingly as we have some extra change appearing. So some kind of dependencies also is the need of that change, right? So dash, a dash and a double dash. So that is like a change we have in the actual image. So when you push that, so when actually it is getting applied into the environment, wherever it is for the actual need. So there we have only the differences coming to that particular place. So only that part of that particular change will be applied to your image. Right? So I just told earlier that we have like layers in the image. So we'll have that in detail, but that is what like the layered approach. So we have additional layer of something newly added to the image, and that will be added to your existing image. So instead of fully pulling this as a fresh image, maybe only some differences we are getting. So that is something about the registry and how do you provide a change in form of again the image, but not the full, only the difference. So here we have most of the components or objects listed. So images, containers, networks, and volumes, these are basic. And then you can also have some additional plugins or some other objects if they are required for your application. So that also you can utilize. And on the bottom side of this, we have a straightforward like a pipeline for having your requirements mainly, what you need as part of your application, like service A. So there you have to mention all your stuff, requirements, and out of that, you can build the image, and that image will have all the dependencies. And then after, you can actually have a running that particular image, and that we call like a container. So it will be like a runnable instance of the image. So with a container, you can easily have attachment of like a storage, which can be your DB related storage, or like a simply like a file related storage, or you want to attach to some network as well. So all are the possibilities if your if your application is quite complex. So you can try out all those in your application later on. So once we have gone through all this, I think contains we have around 3 sessions. So we'll have more details also onto that. So how do you check a network? For example, we have the container with this name, Nginx test, for example. So if you want to check related to the network details, then you can issue some commands. So accordingly, it will provide you details. What are the IP related details? So then you can interact with that. And later on, you can also switch to that particular container, and you can exploit whatever is the functionality available there. So when it comes to network, we have 2 or 3 possibilities. One of them is bridge. Then second one, we have the no network requirement at all. And third one is like we want to utilize right from this machine. So of that machine only, we want to utilize the network. So for the first case, we have some separate network creation inside the Docker host. So there we have like a bridge arrangement, and whatever IP address range you are finding on screen, that is 172.17, and let us say /16. So the 16 bits you can use for all those various containers, right? And the first entry into that is bridge, that is 0.1. So everything is like connected like this as a single network. All the elements or the containers are connected via that. And otherwise, we don't need any network connectivity, then we say network equal to none. So these are all the commands from the command line, docker run, and then we have the subsequent extra commands as per your network preference. And third one is network will be your host itself. So there we are straight away declaring that your container will be utilizing port number 5000 of the machine. So directly in that case, like you obviously you cannot utilize that for any other container. So that is just an explanation. Otherwise, this is the story of every process. If you have something running on this machine, then you cannot initiate anything else onto that machine. So this, if you recall, while demonstrating that API related stuff, so we used this as well. So when you run a particular container, it is not a complete command. There are some parameters missing in this, but we are just trying to focus on to the network part here. So our machine is identified like this IP port combination, and internally we have like a bridge arrangement, right? So that first command, if we have given, sorry, this is default, right? Yes. So by default, you'll have a bridge only. So when if you do not specify anything like this, network equal to something, then it will be like bridge only. So here we have a bridge arrangement, and inside that we have multiple containers, and all of them can have different IP addresses as per the range, whatever we have for that particular network, which is internal to the host. And you can have multiple such networks inside a particular Docker host. And later on, you can scale it to multiple such Docker hosts. And again, there also you can have a particular network spanning over a particular set of machines. And so those are all more complexities of how you can play with the network. So that we will be discussing in the third session. So not only this kind of network we can have, but on top of these three machines also we can have a kind of network, and there we can have again the applications interacting via that networking arrangement. So here we have a bridge in between this native machine IPN port, and over here we have IPN port. So when we do this Docker container run, and the port number specification is like this. So that is first one is belonging to the host, and the other one is belonging to the container. So when we do this, so it is just trying to actually link both of this. So port of the host machine will be linked with the port of the container. But in that case, it will be also depending on what is the IP of that particular container, which we are just referring is the second part of this command, which is actually not present on the screen. So that is the understanding of the network related parameters you need to specify when you are exposing any service like web server is hosting your API calls, for example. So I suggest that just try out your APIs you already deployed, right? In your practical 2, you already tried that. So just try to try having your application hosting inside a particular container. And for that, you need to specify some requirements as well. So maybe tomorrow we'll be able to complete that part as well, and more details related to the volumes and various commands as well, and more stuff related to the images and whatever kind of layers and all that. So that we'll be discussing in the next session. So if you have any questions, I'll wait for some time, and then we'll stop for today.